All right, we've got integration by parts. I know that the last section and this section are challenging, but I think it goes downhill from here. So let's fight through this. Basically, integration by parts is when substitution didn't work, or it's an alternative sometimes to substitution. Power rule, where you increase your exponent by 1, divide by a new exponent. Ease, natural logs, that kind of stuff. Basically, you end up in a corner and you can't figure out your way out. So first of all, I probably should have told you this way back on the first section, but I told you this at the beginning of the semester. If we're looking at differentiation, if I ask you what is 2 times 3, then you would say, oh, it's 6, hopefully. But bottom line is that differentiation, there are rules. You find the scenario, you apply the rule, and then you're done. Okay, but what happens if I ask you and say 24 is the answer? What was the question? Okay, so there's a multitude of different ways to get to that 24, and that's integration. So you always want to try and find the best path, the fastest path. Sometimes there's a couple of different ways that you can approach it, but your mission is to find the quickest path. So integration by parts is going to be a new strategy that we use, and basically you'll know that you can use it if you're trying to undo the product rule. So if you've got a product, and remember, you can't use quotient rule or product rule on integration because you're trying to undo that stuff. So basically, if you've got a product and you can't find your way out with integration, then try integration by parts. So what you're going to do is you're going to identify a U for substitution, and then you're going to identify a DV. And traditionally, your DV should be the more difficult of your two options, the one that looks harder. Okay, and then the formula for integration by parts is going to be U times V minus the integral of V du. So that's the formula you want to have in your head when you're working through this stuff. Now, that being said, we don't care about that anymore. All right, what we have is, and I'm just going to tell you right now, most of these say, can you use substitution, or do you need to do integration by parts? Every single one of these, unless the algorithm goes screwy, you're going to have to use integration by parts. I'm just telling you that right now. So what we have on the first one is a 4x and then an e to the 3x dx. All right, so what's the issue? If I were to use traditional substitution, my u would be 3x. The derivative would be 3. Okay, well, I have an extra x here, and that's what's messing everything up. So I'm going to try a strategy of integration by parts. So the first thing is you want to find a u and a du and a v and a dv. And I'm going to continue to set it up this way. From your original integrand, you want to identify your u and your dv. Okay, so which one looks more difficult? Does the 4x look more difficult, or does the e to the 3x look more difficult? Well, I think the e to the 3x dx looks more difficult. So the one that looks more difficult, you're going to assign as your dv. So e to the 3x dx is going to be my dv, which means the 4x is going to be my u. And notice that your derivative or your derivative notation will always go with your dv. Okay, so you're not going to randomly put a dx up here. Anyway, from here, you've taken this from your integrand. You're going to differentiate this way, and you're going to integrate this way. So ignore this for a second. Take a derivative. So the derivative of u is du. The derivative of 4x is a 4 dx. Okay, we've been doing that the whole time. Now we're going to integrate. So if I integrate both sides, and now I am going to have to do a little bit of substitution. I know I'm sniffing, and I'm so sorry, that's gross, but I'm fighting a wicked cold. All right, your u would be 3x, and not this u, okay, just substitution, would be 3x, so your du would be 3 dx. I'm missing a 3, so I need to balance with a 1/3, okay? So now the integral of e to the u du is e to the u. So my 1/3 is coming along for the ride. And this is e to the u. So he's e to the 3x. Okay, so again, how do you check your work? Take a derivative. So rewrite what's sitting there times the derivative of your exponent means your 1/3 would reduce out, and you'd be left with e to the 3x dx. Okay, that's the hard part. Now what we're going to do is shove that into the formula of u minus v, or sorry, u times v minus the integral of v du. So what is u times v? That's the first part. So 4 times 1/3 is 4/3. And then x e to the 3x. So x e to the 3x. So uv minus the integral of v du. So v du is going to be this way. And I've got a constant of 4/3. So I'm just going to pull the constant out front. And I do that out of habit at this point because I'm pretty dang sure I'm fixing to have to balance something. So I have 1/3 times 4 is 4/3. And then v, which is e to the 3x, e to the 3x, du. Well, I've already got my 4, so just slap down your dx. So this part's done. He's coming along for the ride. All I have to worry about now is integrating this. Okay? So now I'm back to square one. Can I integrate e to the 3x? Well, my u would be 3x. So my du would be 3 dx. So I need a 3. So balance with an additional 1/3. The one that's sitting there doesn't count. And so my final answer is 4/3 x e to the 3x minus, so I just copied this, 4/9. And then e to the u du is e to the u. So e to the 3x plus c. So that's a way. Now, if you did product rule on this, and if you just did just differentiation on this, that would go to 0. And if you combine like terms, all that kind of stuff, this is what you get back. So you're undoing all this. So let's try it. That was a long one. All right, so let's try this again. We have a 9x e to the 1/7 x. Okay, so a 9x e to the 1/7 x dx. So again, the derivative of my exponent is 1/7. So this x is what's causing my life to fall apart. So my u and my dv are going to come from my integrand, and the one that looks harder is going to be my dv. Okay, that leaves me with a 9x here. So here's your du, and here's your v. So the derivative here is going to be a 9 dx. And then again, you're going to have to balance. So be careful. I need a 1/7. So if I need a 1/7, how do I balance? I multiply by 7. So this will be 7 e to the 1/7 x. Okay, so differentiate going down this way and integrate going up this way. So now my answer, or the next step, is uv, which is going to be 9 and 7, is 63x e to the 1/7 x minus the integral of v du. So take care of your constants. There's a 63 times the integral of e to the 1/7 x. So that's that part, dx. And now I just have to integrate this. So I need a 1/7. So I need a 1/7. So balance with a 7. So 7 times 63, I'm not even going to try this. So 7 times 63, sorry, is 441. So I end up with a 63x e to the 1/7 x minus 441 e to the 1/7 x plus c. Okay, so that is your final answer on that one. And we got time for a couple more. So it's really just getting the hang of that integration. So I've got the integral of 8x plus 5 over e to the x dx. And I'm going to bring this exponent up top, or this e to the x up top with a negative exponent. So I actually have 8x plus 5 e to the negative x dx, and that just makes it a little bit cleaner. All right, so I've got a u and a dv, and then I'll differentiate, and then I'll integrate. So of these two options, which one looks harder? That one does. So e to the negative x dx will be my dv. Well, what's left? 8x plus 5. will be my u. So take his derivative, I get an 8 dx. Now integrate this one. The derivative of your exponent is -1, which means I need a negative, so balance with a negative. So I have a negative e to the negative x. Okay? So uv gives me a negative 8x plus 5 e to the negative x minus the integral. Well, if I minus a negative, it's going to be plus. So minus the integral of v du. And I'm going to go ahead and pull my 8 out front. So I'll have an e to the negative x dx. So all I got to do is integrate this, and I'm done. So this comes along for the ride. So negative 8x plus 5 e to the negative x. And then the integral of e to the negative x, I need a negative, so balance with a negative. That gives me a minus 8 e to the negative x plus c. Okay? Now in Cal 2, which this is a Cal 2 concept in most places, you would have to do multiple levels of integration by parts. And so basically what that means is that this would also have to break down, and then you'd probably have to break it down a third time. And so we're giving you a Cal 2 concept, but we're keeping it as abbreviated as possible. And again, I know you're just like, this is a freshman course, but we're almost done. Okay? Let's get through this section, and then it's pretty much downhill from there. So for number 4, we have 7x e to the 3 minus 4x dx. Again, this x is what's causing the issue. Okay? So my u and my du, and then my v and my dv. So of your two options, either 7x or e to the 3 minus 4x, which one is harder? This one is. So e to the 3 minus 4x dx. That leaves me with the 7x here. So his derivative is 7 dx. This one, your derivative of your exponent is a -4. So I need a -4, so balance with a -1/4. And then I'm left with e to the 3 minus 4x. Okay? So uv, 7 times a -1/4 is -7/4. X, e to the 3 minus 4x minus the integral. So minus a negative is going to be plus. 7 times a fourth is 7/4 of v du. So e to the 3 minus 4x dx. So all I got to do is integrate this. Well, I need a -4, so I'm going to balance with a -4 out front. And so now I've got a -7/4 x e to the 3 minus 4x. This becomes a -7/16. And then I've got an e to the u du. So e to the 3 minus 4x plus c. Okay? And I don't think I have time. I only have 2 left. No, I don't have time for those. All right, so I'm just going to wrap up the last 2 in a separate video. It's broken.